happy to co-present this talk, because there are some of the challenges of today's world, and we'd like to show and demonstrate how two cutting-edge technologies like Apache Kafka and Apache Ignite can be used together to solve those problems.
Yeah, but before that, how many of you folks have a Twitter here? Anyone? Twitter. Like this is a small social network that 140 characters. Yeah? Yeah, so you can tweet about this presentation if you see something that you like. We always appreciate support also. All these like basic points that someone has mentioned on Twitter. And for make it more easier for you guys, Denis's Twitter handle, my Twitter handle, and you can tweet about this. All right. We already got introduced, so we will skip this slide for no reason.
Yes, so like generally speaking, why this demo makes sense, because there are some of the challenges which were caused by the digital transformation. And those challenges are the following. First of all, now applications and services of all kinds, they're experiencing huge volume growth for queries and operations. Like 10 times or 100 times or 1,000 times more operations and transactions have to be completed. What's interesting is that that's not just related to the volume of your operations, but also related to the volume of your data. All of those 10 times or 100 times more queries have to be executed across 50 times or 100 times more data, right? And that's no longer about operational data sets. That's also about analytics. So companies, yeah, it's fine if you have some banking application, you'd like to check your bank account quickly, do a money transfer, etc., it's all understood. But at the same time, now businesses would like to do real-time analytics. What does it mean? Let's say the same bank, right, wanna give you a loan, and it's like beneficial for the bank to check your profile, your history, etc., in real time, in a matter of seconds, but not like overnight. And that's why when you can have both analytical data and operational data merged together, and that's like sometimes
I'll give you another example. This actually happened like last time.
All right.
So I was shopping for some like for gear for skiing, and I just ordered a like ski mask. And this morning, like when I started my day, I opened the email and I got this email saying, "Oh, I'm sorry, your order was canceled because like we checked our warehouse and information on the website was disconnected from this one." And I tried to talk to the customer support saying, "What the hell? Why you didn't tell me like when it was like real time, when it wasn't on the website? Why you didn't tell me?" "Oh, our system works overnight, and the end of day process is the end of what day, right?" So. And it was like a broken customer experience, and they lost me at hello, and we canceled your order. So I think this is where we're on the edge when this like not only for real-time fraud detection, all some like stuff like space and continuum, but like it's affecting customer experience, just simply trying to run the electronic business.
And those are examples of business kind of challenges, but when it comes to
this is exactly how it starts. Like if you start small things, you start the application, you start running an app, like okay, so let me write this like a small app that will talk to the database, right? So now you're building this small app, and after that you're adding a few more apps that communicate with the same database or communicate maybe some data warehouse in the system. Like now you need to implement your payment system. You're introducing some like a SaaS solution, or maybe you putting some marketing the tools from the SaaS platform. Microservices, we're doing this like everyone is doing microservices. How many of you are doing microservices today? Okay, good. How many of you are doing monolithic applications and you're enjoying this? Right. I'm interested in what the other people are doing. Who's not doing microservices but not doing monolithic? Yeah. Okay. All right. So that's a good point. Yeah. So essentially, it's not only happening in the one place, right? So it's all over organization. So you have a different line of business that does similar things: apps, the integration with the SaaS systems, and so far and so on. Now we want to go to cloud, right? So everyone's going to cloud these days. Something is happening in the cloud. And very soon, this like things that
something simple,
something simple becomes exactly it's an attraction park or like Disneyland, something like this, right? How many have seen this in your architectures when you're talking to your data architect? or like some architect that you implement in a new project, right? And after your life, I didn't like it definitely. So this is something that we do not enjoy, right? So we need to find a better solution. In most cases, it's not about what you do or you don't do, right? So it's more about like what you don't want to do.
Yeah, right.
So in this case, like writing a scalable system that will allow you to like ingest data and stuff like that. It's like you want to focus on the business. You want to solve the problem of this guy who's buying your schemas. So
and here's like if we have to accept that the business will only be evolved, right? So we have to continue running all of those operations, but we want to get rid of that mass application and services mass, and at the same time we want to come up with clean and simple architecture.
yeah.
And our goal of today's presentation is to introduce you one possible architecture, which is built together with Kafka Confluent and GridGain, which is enterprise version of Apache Ignite. So generally speaking, Kafka is seen as our core backbone streaming platform, and
That allows us to like I love this like performance buzzword,
Yeah,
or like a
buzzword.
data velocity buzzword. So essentially, the things that we just talked about is like when you increase the number of the systems that need to communicate, the data starts flowing, and we want to react on this faster. Like we need to have like event-driven the system that allows to perform very well in this one. And plus, performance is always huge concern. Like you cannot wait for slow disk, you cannot wait for like even flash drives faster, but in memory things is even faster.
This scalability, right, performance comes how the performance, right, gain is achieved. Both streaming and storage solutions are scalable. For example, scalability, right?
Yeah.
Which means that whenever you need to increase your sustain kind of larger workloads, more operations, etc., then just scale out your Kafka cluster, scale out your GridGain cluster. That keep petabytes of data doesn't matter, like the volume is not needed. And also like, and kind of from the processing standpoint, right, we want to unite operational, streaming, and analytical data sets. And today we'd like to demonstrate how to reuse our knowledge we gained working with relational databases. We're going to demonstrate how to use SQL for both stream analytics and for end-to-end storage analytics.
Yeah, so it can be talk where we can talk to developers, or we can talk to we want to talk to data analysts. Do we have any like experts in SQL here in the group, or at least know what SQL is? Like who's enjoying writing SQL these days? Still?
Yeah, I would ask you a question differently. Who doesn't use SQL?
Rest of people still eating pizza. Okay, right. Okay, cool. So we have microservices people, SQL people, we have knowledge people, and the rest of the people eating pizza. Right. So we will drill down to this component, like to this guy. So this we start with this one. So how this streaming platform allows to integrate things into one place. So essentially, you might remember this like spaghetti architecture, all this, or how they call it, like amusement park architecture, Wonderland architecture. Yeah, and this is where the streaming platform or event streaming platform as Apache Kafka as a foundation comes into play, and it becomes a kind of like central neural system for exchanging the data. And actually, it unifies the way how the data exchange between multiple systems. And we will be focusing on these aspects. We will be focusing on communicating with these data stores like GridGain and how the data will end up in the system. And we will be using this like a small app written also in SQL, right? That will be performing some of the real-time alerting type of thing, right? So, how many of you are familiar with the CAP architecture here? The CAP architecture is evolution of Lambda architecture. For those of you who don't know, this is your first homework assignment that you will go and Google some of the interesting things today. So essentially, CAP architecture is the evolution of Lambda architecture, what was essentially the way how to deal with the large amount of data, but with increased velocity. So where you have a Hadoop world, which is your batch process, that gives you ultimate correct result, but this result is end up on the end of the day. And in the Lambda architecture, you're also introducing speed layer that allows you to get immediate results, or maybe results for the last hour, last minutes, etc. But it doesn't give you exact result because you don't have a full picture. So that's why you run this batch job overnight to reconcile the speed layer yourself. With the introduction of the Lookup architecture, where we have a streaming platform that allows us to eliminate this Hadoop thing with the stateful stream processing, we actually getting much nicer architecture. So we have a connector that will bring some of the information of the market data. This is why we have the money here. So this is how your money comes flying to Kafka. And after that, we're using the same interface, Kafka Connect, we will dump data to GridGain for further analytics. So in this case, we're using these two connectors as example, but in this case, any Kafka-enabled data store can be used as a sink, so data will land in this data store, or it can be used as a source. For example, here, some of the change data capture or some change events will land from GridGain into Kafka to Kafka Connect. All right, so let's try to fire this beautiful laptop with some stuff.
Yeah, before we get into the details, right? So what we're going to demonstrate, some template for this architecture discussed. As Viktor pointed out, we created a special demo which emulates market orders. Let's say that some of the companies just put some stocks in the market and there are some buyers. Pretty classical situation. And GridGain, right? Again, GridGain is your distributed, scalable storage which keeps data both on memory and on disk. Kafka, Confluent streams all of those market orders into the cluster. Here is on my laptop, I have 2 nodes GridGain cluster studied. Nothing just installed. I can run the same demo from my laptop. No need to no need to do anything else. And here is I have this monitoring dashboard. So generally speaking, I'm connected from this outside to my local cluster. I can see that there is no any log yet. I have some of the tables created, like market order and buyers, we are going to use them for some of the SQL queries. But that's it, the tables are empty.
Let's bring some data in and see how this beautiful magic technology actually works. So essentially what we'll do, we just grab this, initialize the connector. So first of all, we're using the Confluent platform, which is one of the distribution of Apache Kafka that comes with some of the productivity tools, plus comes some of the tools that are not included in Kafka. For example, schema registry for managing the Avro schemas for your payload, REST proxy that allows you to communicate with the Kafka cluster without writing apps, and KSQL that we'll be using right now. So to start doing something, we need to we need to load 2 connectors. And okay, we're in the right directory. So what we'll do, we will load the connector that will be dumping everything that goes on a particular topic in Kafka. We'll dump this into GridGain. So in this particular case, we see this connector is up and running. And in my control center, which is another productivity tool that's available for development for your use, immediately reflect that I have this connector. So there's 2 types of connectors, and I will drill down on these types a little bit later. But one connector type is a source connector that brings data in. Another type of connector is a sink connector that dumps data out. So we have all this configuration here. So next thing, we need to have a connector that will bring data in. In this particular case, we will using this a custom connector that will be reading data from emulated market data source. In this case, when we bring data in, we see there's market orders connector. And also what we will see here, hopefully, that there's a topic where the data will go into. So if I'll see what data comes in, so now it goes to internet, from internet it goes to our source, and after that this market orders flies in. So it works. Oops, sorry. Once again, you know this, it goes to internet, from internet it goes to laptop. Always demo work on a laptop, and most reliable internet you have on Wi-Fi during presentation. So this is data that comes in the real time. So there's why there was a lag when we're waiting that the data will start arriving in Kafka topic. So this is data that will include our information. In this particular case, it will include symbol information, the quantity of the particular ideal bit price, trade type, timestamp, etc. So next thing, it's good that we have some data here, but can we analyze this as data flies? So if I can do here, so first of all, I'll go to this particular topic and I will say a query in KSQL. In order to query this KSQL, I need to provide the structure. So KSQL is this streaming SQL for Apache Kafka that allows you to perform SQL operations on the data. So in the control center was able to introspect what kind of data goes into this topic, and it automatically generates this schema, like from the JSON schema, right? So we have this thing, we're just saying that our symbol is going to be our key. So in this case, we will have all information for a particular symbol will land in the same partition. And the timestamp obviously will be our timestamp. So we have a create a stream, and okay, so we want to have it in a JSON format or Avro format, yeah. And after that, our favorite select star query that, I mean, you wrote select star type of query today? Anyone? All right, cool. So this is thing that we call stateless stream processing, right? So you're just querying some data that doesn't require you to do anything with this. So there's two types of stream processing. One is the stateful, another is stateless. In order to perform some of the results, you need to, in order to perform certain result, you need to have some information from the past. It's called stateful stream processing. Every time you do aggregations, every time you do grouping and stuff, it is performing stateful stream processing. Now, so let's run this. Actually, it's pretty cool. It's a full-blown straight stream processing application. So, and what it does, I always wanted to type this, but Denis not allowed me to type, so that's why we copy and paste it here because of limited time. So let me show you quickly. So what are we doing here? So we're getting another stream from the stream of this market data, and we want to know that what's going to happen like every 10 seconds. And if the bid price of this particular stock was more than 500 or whatever dollars, and it was like more than 10 operations, we want to create another derived stream. So let me stop the thing, and I will perform this computation. So we're waiting for this window. Data will arrive, and some of the data will pop in. There's a lot of data coming in, but not all the data will be feed into this particular query. So obviously the Google fits very well. And also interesting aspect here. So this query will be running only while this window will be open. If I want to have a persistent query that I can get access even after this will be done, I can do something like that. Create a stream as something. Test 1, create stream, test 1, so this is why then it's not allowing me to type because I'm doing typos. And this is how we will create a persistent create stream. Yep, there's plenty of room for mistakes during typing. Okay, and just run, select table, create save. Do we have it saved? No, we don't. Anyway, so I'm typing it wrong. So this stuff is actually performing. Let's figure out why it says. All right, produces a table. Okay, so in this case, we cannot create a stream because we need to have a state. So there's a difference between streams and tables. Stream represents the history of the things. Table represents your state. For example, we have a state stream that represents your ledger, every operation that happens on the account. But if you want to have a account, you want to have a total balance or the current balance. In this case, you have this in table. So this is how you differentiate between streams and table. So I'm saying here, and here I'm getting this the aggregated value. So in this case, it's not a stream; it is a table. And this editor is smart enough to suggest me this stuff. So now this test 1 is gonna be persistent query. It's constantly running and constantly producing this data into this particular topic. So in this particular case, I can always go here and inspect this, and I should see this result that comes from this computation. So this KSQL process will be constantly computing this data, and this data will be constantly landing to this topic. So we will wait for more data. Now, on the GridGain side of things, you wanna show
Yeah, sure.
how we can perform the same stuff,
Yeah,
like
while,
with the same
yeah,
SQL?
while Viktor was showing you how to.
Yeah, we'll have some Q&A, so just hold on to your question because we have a limited time here. Yeah.
Yeah, because like while Viktor was showing you how to analyze live streams of the data, right, using SQL, GridGain was being fed with all of those data sets all the time, right? Now if we go back to our console.
Can you show like this market order table? So in this case, our connector automatically lands some open order data through Kafka into GridGain.
Yeah, give me a second. The internet has a lag. Yeah, so here we have, let's say, a lot of data, right? More than 3,000.
It's weird because the market should be closed, right?
Yeah, but anyway, now I have some of the queries predefined. Let me find the market orders. So here is like we are going to run the same query, but what's the difference, right? If on the Kafka end we were analyzing live streams of data, here is we're assuming that's your final data storage. That's your database, which keeps data in memory so that we can process all of those queries much faster, and also it persists all of the data sets to disk. So like this time, we are going to execute this query over the data which is sitting in GridGain. Also, let me try to do the following. I'd like this query to be repeated every second. I just want to show that the data keeps changing, right? You can see that this kind of table is being updated in real time. That's like the data flows from Kafka to GridGain, and here is over the GridGain we are running our distributed SQL with joins, etc., trying to aggregate data sets. And finally, here is what else we have. Let's see who are the top most buyers and what type of stocks they prefer to pay for. So here is, we can see the following, that those guys tend to spend the most, not these guys, yeah, like the most, like Apple stocks, like take 20% of the deals, like then we have something like Baskin Gas, and you also can repeat the same procedure. Let's run it just in real time. I think we need to change some charge setting symbol. Alright, let's repeat this in real time, and this will be changed. So the idea is just pretty straightforward, right? Data flows. You have some real-time snapshot of your data which is coming through Kafka. You have your final database which is distributed, and you can merge your memory data sets with these data sets using SQL, right? SQL is probably one of the simplest APIs, and both technologies which are distributed by nature can run that SQL operations in a distributed fashion, no any issues. So like that's the world we are living in. It's no longer about relational databases if you like to run SQL. If you model your data sets in the proper way and distribute the data, then you can run your SQL as efficient as with relational.
And you can run this everywhere on analytical storage where data already landed, or you can create a SQL where all these messages will
all right.
go through.
Let's then check like how this.
Let's go with 2 slides.
A couple of more slides, please.
No, oh. All right. So let me explain what exactly happened here, right? So a couple of things here. So Kafka Connect is a pretty cool piece of software. It's a part of Apache Kafka. It's actually a framework in runtime. So typical how the application will deal with Kafka. You have some system where you read it from somewhere. You can read it from database. You can select your stuff, and after that, you need to write this application called a producer. So in this case, there's a Java API. There's different languages for different clients for different languages, and data land in Kafka. Same thing with if you need to get data out of the Kafka. In this case, you can use this application called the consumer. You read data from Kafka, and after that, massage this data in the format that final data store required. So essentially, if you think about this, depend on the number data sources that you need to support. This part, the left part, or right part, or right part, left part, whatever, will explode because you need to write, for each data source, you need to write your own application. So the Kafka Connect actually provides the solution for you not to do that. So what I like to say, like, it's not important what you can do with this framework. It's more important that you what you're not doing with this framework. So you're writing the best code, so you're not writing code that you need to eventually support. And only thing that this will be running. So this is connector code, and based on this connector code, we can perform a couple more applications. So for example, there's a thing called SMT, which is a single message transform that allows you to perform transformation of the message before it lands in Kafka. For example,
if we're taking like this example, right, our demo, we created a simple connector, which was connected to the internet, like from this location where we were consuming all those market orders. But before the data was pushed to the Kafka cluster, we would just prepare it, like cook in a special format, right, so that it can easily consume.
Yeah. So, and there is a thing called converter. So the Kafka doesn't give about your data, because Kafka stores bytes. So it doesn't know about schema, doesn't know about structure. So in order to make sense of some of the data, there's a component called converter exists that will perform serialization in a format that Kafka Connect will understand on the other side. So in this case, we're using the JSON converter, so data land in our connector. When we write this data in a JSON format, it's going to be like BTF binary string. Now, so from consumption perspective, we have this GridGain connector that is like certified connector and available Confluent Hub. We will talk about this in a moment. So this connector actually reads the data from the Kafka and pushes data to GridGain. Again, it has a standard way how to convert the data from the format that stores inside the Kafka in binary format in the format that GridGain will understand.
Yeah, like so from the application developer standpoint, right, what we did for this demo, we developed only this sample Kafka producer, right?
Yeah.
The rest of the stuff was all about configuration. We downloaded connector, we started Kafka cluster, GridGain cluster, some of the settings, and that's it.
We could use Twitter connector, but people are tweeting here, so this is why we decided, okay, so we're not going to use the Twitter connector, we're going to be using some of the market data that people can relate to New York, right? Okay, so where to get these connectors, right? So where you go for connectors? Right? Ask no more. Dennis, where you go for connectors? Where you need to find a connector for your system?
I download them from this Confluent fabric.
So yeah, at the Confluent, we developed this kind of like app store of connectors. And if you need to find the way how you integrate the Kafka and event streaming platform with any external data source, so you go to this confluent.io/hub, and after that you type your connector. So if you go there and type GridGain, you'll find this GridGain certified connector, and you'll find all information where you can get documentation, how to install it. There is a special client that allows you to install it just very quickly. So you don't need to just download yourself on zip, obviously you can if you like. So now, and where we stand in terms of like a processing, right? So we usually, like, I'm a Java developer, right? I enjoy writing Java code, but how many of you Java developers here? Yeah, so it's just like 5 more. Yeah, so who cares? So in this case, the majority of the people essentially using something more high level, and they want to use tools that they already know and use. So this is why we at Confluent we developed this streaming SQL engine for Apache Kafka that allows to perform same type of queries that you love from your database engineering days, right? And we actually will play around with it, and we just use like similar queries, and the logic will be the same. So differences might be a slight difference between what the Kafka KSQL supports. For example, it supports streams. There's no streams word yet in the SQL format, but essentially all the things with aggregation work exactly how we expect them to do.
Yeah, like what was done on what was used on the GridGain, right? I know kind of a couple of more minutes of the time. First of all, from the streaming standpoint, why all of those streams were easily kind of digested by GridGain? Yes, we just studied that GridGain sync connector developed for Kafka integration, but then internally GridGain provides all of the streaming hooks. Let's say that here you have your GridGain cluster running. Here is my stream, some different streams. In this case, here we had Kafka. The data would arrive, and the data would be streamed GDP to the nodes, which store primary and backup copies of our data. And then on the other side, we had our applications. In this demo, we use just console, GridGain console, just the tool, right? which executes all those queries. From the APIs, we demonstrated SQL, right? And I'll talk a little bit about it in a moment. But also for the streaming, what makes sense, computations, right? What we find being used a lot. That's when you have some of the logic written in Java.NET or C++, and instead of pulling data with SQL to your application, so you can execute this logic in place on your database end. Think about Hadoop MapReduce paradigm. The same concept. Created logic and logic gets executed there. That's like what we see being used a lot for.
Or think about the sort procedures type of thing, but in distributed world, and the sort procedure is actually written in some more or less, good language like Java, or something else.
Yeah. So here is like that's a good relation. But here is you can use all of the APIs of Java.NET or whatever. And finally, like SQL, like how that SQL works in the distributed world. It's all that simple. And take other technologies like Google Spanner or like MongoDB, MemSQL, etc., or Oracle times 10, right? If you distribute the data properly, model your data sets properly, then even execution of joins, aggregations, etc., it's not a big deal. So like here, as you see that we have two tables, cities and countries. All the cities of a particular country are stored on the same machine. And when you would like to join data of two tables, you will not have any data movement
Probably there.
in there. And so between your cluster nodes, the data will be joined locally on your database edges, and then final data aggregation will happen on the client side. That's how simple it is. And finally, one last thing, right? Today we demonstrated how to stream data, store data in memory, in the cluster, etc. on SQL. But let's simulate the final thing, because all of the bad stuff happens, right?
Yeah, if it breaks.
Yeah, what happens if it breaks?
It's in memory, right? So in this case, we will lose all data.
Yeah, like we have the whole data set in memory. Now let me stop GridGain cluster and killing all of the nodes. And also let me destroy like total full cluster, like full data center failure.
It's like you decide to
like
very atomic and the nuclear that all people expect.
So generally speaking, by some reason only like this web application works. Let me see that the cluster is down.
It's cool that your console was not in the...
Because it's deployed outside. It's like I'm just connected. Nothing, like cluster is unavailable, right? But what happened to our data? Now let me restart my cluster, which kind of cached all the data sets in memory. But also at the same time we had persistence enabled for GridGain, right? Which means that we lost nothing. It's like now once the cluster is restarted, let me ensure that this happens successfully. All right, all of the nodes are up and running. Let's go back to the console. Data is loading. So what's about the data sets? Yeah, all the data is here, but nothing is in memory. Nothing is in memory. All right, now, we don't need to warm up our memory. In GridGain, you can run all of the operations and they will go straight to disk if nothing is in memory. Let me just run the same query we had executed before, and it just works. How GridGain works, if something is missing in memory, it will just go to disk. And that's like how it works. Like you had some failure, you restarted your cluster, the cluster is up and running, and even though we lost all of the data sets which were initially in memory for the sake of performance, now we just still can read all the data from disk. Everything is consistent. That's it. And
very important slide for QA.
But no time for QA.
Yeah, no time for QA. we can actually talk about questions while the next presenter will be, setting up his laptop.
What was the name of that Kafka distro you mentioned?
Huh?
You mentioned the Kafka distro that can do things very
Yeah, it's cool stuff. Okay, so this is the cool thing how you can destroy your clusters. Essentially, the Confluent platform comes with this like a small productivity tool called Confluent CLI that allows you to operate with your local environment and some cloud environment that we support. So essentially, like when you do demos like this, I always do Confluent destroy because I want to wipe up everything and start clean instead of just going manually and removing this directory and stuff. And there's a bunch of other commands, like you can start only Kafka. In this case, when you start a Kafka, Confluent CLI knows that it depends on Zookeeper, so it will start Zookeeper first, and after that it will connect it to Kafka and you can do things. You can start only like a schema registry and the Confluent, REST proxy. So in this case, it also knows that it depends on Kafka. It starts Kafka first and starts Zookeeper first. So it's like very small but important productivity tool. For development purposes, for cloud purposes, if you're running this the Confluent cloud and you're using like managed services, you can also do this from CLI. You can produce the topic, read from the topic, you configure ACLs, configure RBAC permissions and stuff. So it's a pretty cool little thingy that allows you to save some time on just going through the places to start other things manually.
All right, I need to can the stage, but before, like, as long as nobody did it.
Where's
Yeah, let's do like the final stuff. We need to find selfies. Yay! Just do fire. Yay! Hey!
All right, where's the next speaker? So we're expecting someone to take our stage.
Thank you, guys. All right, before we move on to the next presentation, we have more pizza, the drinks, a little warm, but there's a trick. Cups over there, ice over there. So please use it. Grab some ice, pour yourself a soda, or I think we have beers left. All right, so again, guys, we have this tab list here to register for the raffle, which we're gonna do at around 8 p.m., so in about an hour. All right, let's move to the next presentation. Our second speaker is Andy Rivenes from Oracle for database and memory, and Andy is going to tell us about using in-memory technology for real-time analytics. All right, Andy, the floor is yours. About 30 minutes for the presentation, and I'll show you 5 minutes.
Okay.
All right.
Give me the hook when you're ready. So. Hopefully you can see that, but if you can't, you can see me. So, hi, my name is Andy Rivenes. I'm a product manager with Oracle. So, talk about Oracle database and memory. So I don't know, Oracle customers, any of you guys use Oracle? Probably maybe have Oracle with something else. Database and memory is actually part of Oracle database. So with Oracle database, you actually get Oracle database and memory. Oracle kind of does that. We bundle everything together. You don't have to install different pieces of software. It's all installed together. And you can actually try this if you want, if you find this interesting. One of the other things that's nice about Oracle is you don't have to have Exadata. You don't have to have the cloud. You can actually go to Oracle OTN or Oracle.com, we call it now, and you can download a VirtualBox with Oracle database and memory and try it out on literally, I do by example on my Mac. You can do it on your Windows machine. You do it on a virtual machine. You can do it pretty much anywhere. So that's one of the kind of big advantages of Oracle is it runs everywhere. And so you could actually try this out if you find this interesting. I have my email address if you want to fire a question. I'll take questions, but if you have a question later, you want to ask me something, that's the email address. I'll upload the slides to the website as well. We have my Twitter account, but we have a blog, blogs.oracle.com/in-memory. I kind of talk about that as our portal to all information about database and memory. I didn't say this, but I actually work as part of database development. So it might sound like it's marketing, but I really just going to try to tell you what database and memory is, how it works, and how you can make use of it. And that's kind of the gist of it. So I'll talk a little bit about technology. I've done this a couple of times in 30 or 45 minutes. I can't really dive into a lot of technology, but if you want to ask something, please do, because I think people find that interesting. So with that, we'll kind of get started. So safe harbor statement just says don't make any purchasing decisions, but to be honest, I don't get a commission. I don't care whether you buy database and memory or not, although I care if you use database and memory. So the buying part isn't my gig. So why use database and memory? Database and memory, so we call it in memory, but it's really about analytics. So if you have reporting, any kind of analytic reporting, database and memory is probably going to speed that up. And I'll give you some hints as how you can kind of judge that. But the bottom line is I expect that you should get at least a 10x. So I'm trying to figure out if you guys can't really, can you see okay? See around me? I don't know where else to go. So you should be able to expect about a 10x performance improvement in your reporting, analytic reporting. 10x is pretty good. I mean, that's a big speed up. I'll tell you a little bit about why. And I have a customer, we kind of try to say that these are real world examples, not just something the Oracle guy is going to tell you about. In addition to that, that leads into being able to do this in real time, or what we call real-time analytics. Since you can run database in memory on any workload, very often you can actually run database in memory, the analytic reporting, right on your source data. So what that means is rather than having to have canned reports because you're afraid you're going to inundate the system with additional workload for reporting, you can actually run ad hoc drill down queries on data, on the source data, as opposed to having to ETL it to your data warehouse, which data warehousing is a big market for database in memory, because that's where most people do their reporting. But rather than doing that, decision support systems actually being able to run it right on your OLTP or mixed workload environments. And I'll show you a little example, a demonstration we have out on YouTube in a couple of slides. You can go look and see this in really play out. In addition to that, since you can consider the column store, and we'll talk a little about what that is, to be all the columns are essentially indexed, if you will. You can treat it that way in your applications. Very often you can eliminate a lot of analytic reporting indexes that you've had to create. And so you can actually typically gain capacity headroom, reduce your workload, and usually offset any additional CPU usage with the analytic reporting and actually gain total capacity headroom out of this. We actually have some stories, Walgreens, but also on Oracle.com, Bosch, and another customer that uses, which I can't, just blanked on. We have some actual stories about being able to reduce analytic index requirements, which actually justify using database in memory right on mixed workload environments. All of these stories, Walgreens, Price Right, General Mills, plus a whole bunch more. There's actually stories about how they used database in memory that they basically wrote. And so you can actually go see how those companies made use of database in memory. So that's kind of the motivation for why you might want to use database in memory, significantly speeding up analytic processing. Notice I didn't say anything about OLTP workload per se. So we'll talk about that in a minute. So what is it? So it's columnar formatted storage. I tend to tell people we probably should have called this the analytic database option or the columnar database option, because we called it database in memory. In-memory is really just an enabler for the columnar formats and what we do under the covers to scan that data in the columnar format to get the speed up. So that's really, in-memory, yes, but and I'll talk a little bit about that in a second. Accelerated mixed workload, again, that idea of being able to reduce the need for analytic reporting indexes. Indexes actually take quite a bit of resource to keep up to date, and especially in OLTP transactions. So the more indexes you have, typically the slower your transactions will run. Inserting into a heap table is actually really fast. Keeping all the indexes up to date, you have to have persistent, you have to have them on disk, so it takes up disk space. But you also have to generate undo and redo to make them recoverable. And then there's just the maintenance of the index itself. That actually takes up quite a bit of workload. And reducing the need for those indexes can speed up your mixed workload environments considerably. One of the really cool things about database in memory, since it is fully integrated with Oracle database, you don't have to, you can take advantage of all existing Oracle technology, so you don't have to undo anything you've already invested in. And the big one is that you don't have to change your application SQL to take advantage of it. You don't say select from the row store, which is Oracle's traditionally been a row-based database, or select from the column store. You just select from you run your existing application SQL, and the cost-based optimizer decides, does it make sense to access this data from the row store or the column store, which means you can run any of your existing applications without having to change anything and take advantage of database in memory. And that's huge. Oh, I should have mentioned, not limited by memory. So I'm going to talk a little bit about this, but you don't have to put the entire database in memory. If you have terabytes of data, petabytes of data, you get to pick and choose the objects that you're going to populate in the column store. So you don't have to have terabytes of memory to take advantage of database in memory. And that's a big point, and I'll talk a little bit more about that as well. So what is it? Row stored Oracle database has traditionally been a row-based database. We've added now a column store. All changes, all persistence is always in the row store. We haven't changed Oracle's transaction processing mechanism or architecture at all. So everything Oracle database does, has always done, still does. Database in memory is just an additional memory area in the SGA, and in what we call in-memory column store. You allocate it with an initialization parameter. When the database starts up, it allocates this area in memory, and you get to pick and choose the objects that you want to populate. You populate those asynchronously in the background, and then you have the ability to have both row format and a columnar format, and then it's just simply a cost-based decision when the query is parsed. Do I access the data in the row store or in the column store? And you can mix and match. So you could have some objects in the column store and some objects in the row store and combine them with joins, and it will all seamlessly work. Now, it might not be as fast for analytic reporting if not all that data is in columnar format, but it will run, it will get you the correct results. We keep it transactionally and simultaneously and transactionally in sync. I'll talk a little bit about how we do that. And you can run any SQL today and not have to have a huge memory footprint, which most of our Oracle customers don't have. So most Oracle customers don't have terabytes of memory in their database servers. Typically 500 gigs is a lot. And so if you're talking large databases, you have to figure out how am I going to populate that data in this columnar format in memory when I only have a relatively small memory footprint. I'll talk a little bit about that as well. Setting this up is extremely easy. You've installed Oracle database. We introduced database in memory with 12.102, the first patch set of 12.1, and it's in 12.2, 18C, 19C, and beyond. And so all you do is install Oracle database. It's already there. You enable it with something called in-memory_size. It's an initialization parameter, allocates memory that you put or specify with that parameter in the SGA. So that implies that you have to have additional memory that you've allocated to the SGA, but that's the in-memory part of it. And then you just alter table, partition, subpartition, materialized view, and we asynchronously in the background will then populate that data in columnar format. It still exists in row format. All of the persistence is always in the row format. Actually, all data changes always occur in the row format. And we basically keep the column store in sync, similarly to the way we keep indexes in sync, except we don't have to generate any undo or redo because the in-memory columnar formatted data only exists for the life of the instance. So the actual source of record is always still the row store. Because remember, we didn't change the Oracle transaction architecture. Yeah, that's no problem. Find a seat. It's a little crowded in here. And I mentioned in-memory as an enabler. One of the reasons I say it's an enabler is because it's a columnar format that provides the speed up of how we access that format. For instance, on Exadata, you can actually populate the in-memory columnar format in Flash. Typically, Exadatas, I don't know if anybody has Exadatas, but they typically have terabytes of Flash. So all of a sudden, you can go from having columnar format memory in Flash. You can even have it in not in memory format, but you can have something we call hybrid columnar compression. So you can have columnar formats on disk as well. So now you can have multiple tiers of columnar data to do analytics across a very, very large data set. So think of very large scalability. So what queries benefit from database in memory? So I said, I mentioned, I'll talk a little bit more about it, that we don't, the DML, inserts, updates, and deletes are always done in the row store. So what database in memory targets is analytic queries, something I call using aggregation to look for patterns or trends in your data, analytic queries. So from a SQL standpoint, in a SQL query, we're going to typically speed up, if you're spending a significant amount of time or looking at a significantly large amount of data, scans. So if you're scanning data, if you're joining data, or if you're doing group by aggregations, we're going to speed up those queries. Those are the three areas that database and memory targets. I'll expand on that a little bit. But if you're doing millions of rows, sorting millions of rows, if you're spending a significant portion of time transferring results back to the application tier, maybe even bringing rows back to your application tier so you can go through and do row by row processing, database and memory isn't going to help you. Database and memory is based on set processing, where we do the work in the database during the SQL execution, because we're trying to do as much work as we can during the scan of the data. And I'm going to talk a little bit more about that. But it's these three areas that database and memory targets. So here's my slide I threw in for you guys, InMemory Meetup. InMemory Computing. Oracle database has done in-memory computing for a long time. We have the buffer cache, legendary. Multiple pools in the buffer cache. We actually have added automatic big table caching, so you can cache your entire table in memory in the buffer cache. You can cache, if you have enough memory and a small enough data set size, you can cache the entire database in the row store, in the row format, in the buffer cache. In addition, we've introduced in 18C and 19C something we call fast lookup, so key value lookups, all in memory, and actually fast ingest, so streaming ingest, think of IoT type applications. All that's kind of row-based Oracle database. In addition to that, the shared pool and a bunch of other caches like the result cache, speed up memory processing for your application SQL. And then there's rack, cache fusion, running, rather than going to disk, bringing blocks between instances. All that kind of technology's been around for quite a while and has evolved with Oracle database. In addition, it's not times 10. Database, so times 10, we have another PM that comes and talks about times 10. Times 10, row-based, a true in-memory database where you have to put the whole database in memory. High-speed, low-latency transaction processing. That's not what database in memory does, because I kind of said that we don't speed up inserts, updates, and deletes. They do. So they do kind of a different workload than what we're talking about here. So we're just talking about pure analytics. So why not just cache the table? I just told you we can do database or Oracle database can cache an entire table, can cache parts of a table, can segregate memory. You can have it keep it in memory. So why not just cache it in the buffer cache and be done with it? What's the big deal? It's in memory, right? So this is one of the things I do on my by example session. It's literally an example that I run on my laptop. I got a 16 gig laptop. I run a 5 gigabyte column store. Same exact query, line order, the star schema benchmark. If you go to our blog, you'll see all my examples are done with star schema benchmark. Scanning the line order table, exactly the same query. The only difference is a hint that says use basically just run the query, or don't use in memory. That's what the hint in the second part is. It takes a 100th of a second in memory, takes over 8 seconds in the row store. Same exact query, same exact data. There's no I/O going on for the row store. We've cached the entire table in the row store. Entire table is cached, obviously it's populated in the column store. It's literally on the same database. Everything's the same. The only difference is this hint. Notice it says table access in memory full, and it says just table access full. It's almost an order of magnitude difference, and that's just pure scan speed. Serial query, not parallelized. Everything else, apples to apples comparison. That's the columnar format is providing that speed up. They're both in memory. That's why I tell people in memory is really the enabler here, or flash, and so it's really this columnar format that gives this big speed up. So I don't want to beat a dead horse here, but that's one of really, if you take nothing away from this, is remember it's columnar format. That's the magic to get your analytics to basically be able to scan data extremely fast. So let's talk a little bit about the technology. So how do we do this? What's the secret sauce in all this? And it's actually there's columnar formatted databases have been around for a long time. It's not new. It's always been kind of a trade-off. Row-based databases, great at OLTP, transaction processing. Columnar formatted databases, great at analytics. the two don't mix and match all that well. For row-based databases, you got to typically index it significantly and parallelize to get good performance. Columnar formatted databases typically don't do OLTP or inserts, updates, and deletes well, because you have this problem of having to recorrelate the columns back together, or what we call stitching columns back together in order to get the attributes to match up so you can actually change rows, because SQL is row-based. So with database and memory, you kind of get the best of both worlds. And the scan part, so Oracle database doesn't change. Still row-based, still does all the things that you may or may not know about, but still all the same things it's done over the last 40 years. And then we've added this columnar format, so we only have to look at the columns involved in the query. That's huge. In the row format, you got to get a database block, you got to traverse each row and traverse that row to get to the columns you're interested in. With the columnar format, we can access just the columns we're interested in. In addition to that, columnar data vectorizes and compresses well. Typically, we get a 2x to a 20x compression rate on the data. So think about that. If you have a 100 gigabyte table, you're only going to need 50 gigabytes or less of data in the column store, in memory. So that just